because I feel like that section is a pretty new section for most of you. So let's look at the one on the right. So I'm actually going to erase this one and just focus on the one on the right there. So 1 minus u to the 9th power. All right, so when we talk about a difference or sum of cubes, it's really following a pattern. The pattern for factoring the difference of cubes, so let me write that correctly here, a cubed minus b cubed. And Mr. Middleman talked about this in the video. The pattern looks like this. Whatever the cubed root of this first term is what gets written in here. So if that's 64, then we would write 4. If a cubed was 8, then a would be 2. If a cubed is a cubed, then we just write a. The second thing is whatever the cubed root of this term is gets written here. Again, same kind of process. And then what we do is we take whatever we wrote in that first position. So whatever we wrote here, we then square. We do the same thing with b. And then in between these two terms is just the product of whatever we wrote here. So a times b. Now I want you to notice I haven't written any pluses or minuses in there yet. Okay, this is a pattern, and this works whether it's a cubed minus b cubed or a cubed plus b cubed. Once you have this written, then go in and fill in your signs. So the signs follow a pattern. And the pattern is whatever this sign is in your problem, the first sign is going to be the same as that. The second sign will be different. The third sign will be positive. Always positive. Hi, Mustafa. So same, opposite, or different, always positive. That's our pattern. So when I look at 1 minus u to the 9th power, here's what I know. I know that 1 is a perfect cube because 1 times 1 times 1 will give me 1 cubed. Or sorry, 1 cubed would give me 1. So this is just 1 cubed, okay? Now we have to think about what cubed would give me u to the 9th. And it's really simple to figure that out. Take your exponent and divide it by 3. So u cubed is what we need to cube in order to get u to the 9th. Now we have enough information that we can actually follow our pattern. So I'm going to begin by sort of setting up my formula here. I know in this first position, I'm just going to take whatever the cubed root of this is, which we just said has to be 1. Then I ask myself, what's the cubed root of u cubed? I'm sorry, what's the cubed root of u to the 9th, which we've already written as u cubed, and that's what's going to go here. After that, we take whatever we wrote here and we square it, and that's what goes here. So 1 squared is just 1. We take whatever we wrote here and square it, and that's what goes at the end of that trinomial that we're going to write. So u cubed squared, sounds crazy, is u to the 6th. And then we take whatever we wrote here and multiply it together, and that's what goes in the middle there. So it's going to be 1 times u cubed. At that point, we can fill in our signs. And our signs follow that pattern. So it's same, either you can think of it as different or opposite, always positive. So same, which means it's minus. It's always the opposite, which means that's plus, and then it's always positive here. Now what's really interesting about this one, and this kind of goes in with that mixed multi-step factoring, we aren't done factoring this because hopefully you can recognize that is another difference of cubes. So we'd have to go through that same process for that binomial as well. And just to kind of talk you through that really quickly here, you would have, I'm going to set it up, and then I know at the end I'm going to have this expression that I've already written that cannot be factored anymore, okay? To factor 1 minus u cubed, I know that the cubed root of 1 is 1. I know that the cubed root of u cubed is just u. I'm going to square 1. I'm going to square u, and then I'm going to multiply them together. And then once again, the signs are same as what we started with, which is minus. Opposite, always plus. Now this is factored. It's kind of messy. It's maybe tough on the eyes, but it is factored. Okay, so give me a yes or no. Did that help? Lauren, were you able to get in? Okay, I'm seeing lots of yeses. Good. Okay, good. So the other area that I definitely want to talk about is that mixed multi-step factoring. And the reason I want to talk about that is the difference in sum of cubes. We're going to just approach this as if it is a normal quadratic. And that's really the goal here. Think of it as a quadratic. I kind of titled that video as Quadratics in Disguise, because this is really very similar to something that looks like this. So if I gave you what's in the yellow there and asked you to factor it, I'm guessing most of you probably could factor that. Okay, that's a pretty basic trinomial. It's a quadratic. It's a power of 2 as your highest power. For most of you, that does not pose a huge problem. The difference is just in the pattern. So let's just factor the yellow for a minute. Okay, so if we factored the yellow for a minute, going back to our factoring without a box, we set it up so that we know it's going to work. And the first thing we do is we set up the fact that we know that those first two values have to be x's. So once we have that set up, then we think about, okay, what are my values that are going to multiply to be 45? And you just list your possible pairs, right? So I know 1 and 45. I know 3 and 15. 9 and 5. And then I could do all of those with both negatives as well. So I have really 6 possibilities. This is where guessing and checking is going to come into play, but you want to be smart about your guess and check. Okay, so the first thing I'm going to look at is in my trinomial, that middle term is negative, which means that when I add my numbers together, I get a negative number. That's not going to happen when I add two positive things together. So I can eliminate this whole column, because if I add two positive things together, I'm going to get positive things. So that leaves me with the second column. So here's my sort of strategy. When I'm factoring, and some of you may already know what this is going to be, and that's fine, but I'm kind of talking through some thought process here more than this particular problem. The strategy here is I always pick the numbers that are closer together to try first. So I wouldn't try 1 and 45 first. I would try 9 and 5. So I'm going to try -9 and -5. And remember, we guess and then check. So when I check this, I'm going to check by looking at the outside terms and the inside terms and seeing if they add up to my middle term. So that's -5x and -9x. And if we add those together, we get -14. So what I know is that that's the way to factor that particular quadratic. Now here's the thing. our quartic, the only thing that's changing is the fact that instead of getting x squared when I multiply my first two terms together, I need to get x to the fourth. So to get x to the fourth, I need to think about this as being x squared times x squared. Now, some of you may ask, why can't I write x cubed and x to the first? Because that multiplies to be x to the fourth. You would be correct, but here's why. In the next part of this, if I plug in that -5 and -9, when I check my outside and inside terms, I'm not going to get -9x squared and -5x squared, which is what I need in order to get my middle term there. Now, there's one more thing to watch, and what we need to be careful with here is that while this is factored correctly, we've done nothing wrong at this point, it's not finished. And the reason it's not finished is because this guy right here, hopefully you recognize that one. Nobody chose difference of squares as an area where they struggled. It is a difference of squares. So what I know is that I can write that as x minus 3 times x plus 3. And then this is a fully factored version of that trinomial. So it might look a little, talk about it if you have something like this. So this is also a quartic, but it's written kind of funny. So I'm just going to rearrange the terms. All right, I'm going to write this as negative x to the fourth. I'm going to put that as my first term because it has the highest power, plus 5x squared minus 4. Now, I hate when my leading term, my term that has the highest power, has a negative sign in front of it. So here's what I'm going to do. I'm going to think about this as -1 could be a greatest common factor that I can actually factor out. So I'm going to start with that. If I factor out that greatest common factor of -1, it does something nice for my trinomial. It now makes it x to the fourth, a positive now, minus 5x squared plus 4. And then at that point, you can go ahead and finish factoring that just like you would with the previous problem. So I'm not going to necessarily finish that one. I want you to maybe, if you struggled with that section or need to go back and finish it, try to see if you can, if that helps get you started. Does that help? Give me a yes or no. Does that help with Cortex understand your process a little bit better? I'm seeing a couple yeses here. Okay, good. Lauren, to get on Delta Math, you need to go to deltamath.com. When you log in, go to the Tools menu and Manage Classes. And then you're going to put in my code, which I believe is 201597. And I just put that in the chat for you. Okay, so the other couple that seemed to give you some trouble were factoring trinomials with a greater than 1, difference or sum of cubes, and mixed multi-step factoring. Let's go ahead, and there isn't always trinomials when we look at that. And probably more likely than not, you're going to see 4 terms, and you probably panicked a little bit, and you thought, what am I supposed to do with this? Now, I know if you did watch the videos, which I saw quite a few people watching the videos, some of you may have been able to figure out how to do these problems. But let me talk you through another way to do it, and it's going to seem like I'm contradicting what I said in one of our videos, but I'll explain that here in just a second. So the first thing I would do in a problem like this, I look at the fact that this is not a trinomial. It's not a binomial. I don't necessarily have the tools to factor this. But I can at least recognize that there's a greatest common factor in all of those terms. Now, it's not a number, it's not a coefficient, but there is a greatest common factor of z cubed. So that's what I'm going to start with. I'm going to start by factoring out z cubed. So when I do that, I will have z squared minus, whoops, I put z squared. That should be z cubed. Sorry. Let me try that again. Z cubed minus 6z squared minus 7z, oops, good grief, plus 42. So maybe you did that, and then you thought, well, now I don't know what to do. If you watched a video, they probably talked you through how to do this by grouping, and that's fine. And I like that approach, but for some people that can get a little confusing. So let me show you how you can connect what you've done in the past with the box method to actually do this factoring. So I know I told you in the previous video not to use the box. Kind of contradicting myself here, but I'm not really, because I only want you to use this box if you have 4 terms. If you have 3 terms or 2 terms, you don't need the box. But with 4 terms, it can help you organize yourself. And here's why. With 4 terms, you have 1 term for every spot you have open in the box. So what I can do is I can put each term in its own spot in the box. And now I've got to figure out the dimensions of that box. So to do so, I kind of look at a row or a column and try to figure out what the greatest common factor for that row or column is. So maybe I look at this row here, okay, and I ask myself, what's my greatest common factor there? So when I try to figure out my greatest common factor, I can hopefully recognize that it's just z squared. Now that can start setting everything else in motion, because if this dimension is z squared, then we know that this dimension has to just be z. And then that can kind of give us some more information. Again, we know that this is z squared. That's the same as this. So to get negative 6z squared, we're going to have negative 6 here. And we can continue filling in the blanks here. If this guy is z, then we know that this has to be negative 7. And then if you check, negative 7 times negative 6 is going to give you that positive 42 that you need. So we're able to factor this with the box very quickly. Now the approach that they had you use on Delta Math, if you watched any of the videos, was what they call grouping. And it's essentially the same thing. It just happens without drawing the box. So our final factorization of this is going to be z cubed. We can't forget that z cubed that we factored out originally, and I'm guessing a lot of you maybe did. And then we just write down everything else that we had there. Okay. Does that help? Okay, thank you for those of you that are responding. It does help me to know if I'm actually helping out. If you have any other questions, don't hesitate to ask. That's what this time is for. Awesome. Okay, so here's what we're going to do for today. Let me